Hi everyone, I'm going to show you guys how to integrate 3 plus cos theta over 2 minus cos theta. Now for these type of questions, I've done similar questions to these and I've written tan theta equals to 2 tan theta over 2 over 1 minus tan squared theta over 2. Now using this, we could find cos theta, right? Which is going to be 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2. Now I've shown you guys how you get this in my previous videos. It's actually easy because you can see the numerator is your opposite side and your denominator is your adjacent side in your tan theta function, and if you find the hypotenuse, you can find 1 plus tan squared theta over 2. So it's pretty easy. But anyways, if you guys want me to show it, please drop a comment, I'll help you guys out. So instead of using cos theta, we're going to use 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2. So you go back into your integral, you write 3 plus 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2 over 2 minus 1 minus tan squared theta over 2 over 1 plus tan squared theta over 2 dot d theta. Now let's take a substitution of u equals tan theta over 2. Yeah, let's take u. So du over d theta equals half sec squared theta over 2. Easy, right? The differentiation of tan theta over 2. You first differentiate the term you have inside tan, and that's theta over 2. So the differentiation of theta over 2 is half, and the differentiation of tan is sec squared, right? Easy. So then you can write du over so let's do it like this. Let's do a cross multiplication. So 2 du over sec squared theta over 2 dot equals d theta. Yep. So you go back into your integral. So now we have 3 plus, now instead of 1 minus tan squared theta, we could write 1 minus u squared over 1 plus u squared over 2 minus, let's put a bracket, 1 minus u squared over 1 plus u squared. And instead of d theta, I'm going to write 2 du over sec squared theta over 2. Now what's sec squared theta over 2? That's going to be 1 plus u squared, right? Because you know sec squared theta over 2 equals to 1 plus tan squared theta over 2. So therefore, now you know tan theta over 2 equals to u. So all you have to do is 1 plus, instead of tan theta over 2, I'm going to write u, but there's a squared, right? So it's 1 plus u squared. And that's how you do it. So let's expand the denominator, and you'll see you'll have 3 plus 1 minus u squared over 1 plus u squared over 2 into 1 plus u squared minus 1 minus u squared dot d. Okay, so now let's find the common denominator in our numerator. So it's you could do 3 into 1 plus u squared plus 1 minus u squared over 1 plus u squared over 2 into 2 u squared, so 2 plus 2 u squared minus 1 plus u squared dot du. So now let's expand the brackets. So we have 3 plus 3u squared plus 1 minus u squared. So that's going to be 4 plus 2u squared, right? Oh, and there's one more thing. I forgot to put this 2. So you'll have to multiply the numerator by 2. So you could keep that outside the integral. So now it's 4 plus 2u squared over 3u squared plus 1 into 1 plus u squared dot d. Now this is the integral we need to solve. Now since we have this fraction, now we'll have to break this down into partial fractions. So what I'll do first is coming up with the partial fraction for this is it's a bit complex. So an easier method you could follow is you could do 2u squared plus 4 over u squared plus 1. So what I'm doing is I'm going to divide this. I'm going to write 2u squared plus 4 divided by u squared plus 1. So what I'm doing basically is I'm going to divide it by u squared plus 1, and then I'm going to divide it by 3u squared plus 1. So it's basically dividing the numerator by the multiples in your denominator. So when you divide 2u squared plus 4 by u squared plus 1, you can see you get 2. So 2u squared divided by u squared is 2, right? So 2 into u squared is 2u squared. 2 into 1 is 2. So and the remainder is going to be 2. So therefore you can write 4 plus 2u squared over 1 plus u squared as 2 plus 2 over u squared plus 1. But now we have 3u squared plus 1 in your denominator too. So what we have to do is we divide both sides by 3u squared plus 1, and now you'll see you can write 4 plus 2u squared over 3u squared plus 1 into 1 plus u squared as 2 over 3u squared plus 1 plus 2 over u squared plus 1 into 3u squared plus 1. And now you can see we have another fraction we need to worry about, which is 2 over u squared plus 1 into 3u squared plus 1. Now we could break that down into two fractions. Easy. So the way you can do this, you could write 2 over u squared plus 1 into 3u squared plus 1 equals to a over u squared plus 1 plus b over 3u squared plus 1. Now you just need to find the values for a and b. Now you can see the numerator is 2, right? So if your numerator is 2, and you can see in your numerator we don't have u squared terms, so they need to cancel off. Now the usual partial fraction method would be you multiply every term by the common denominator, and then you solve two simultaneous equations to find a and b. But you don't have to actually do that, because you can see the numerator we have doesn't have u squared terms. It only has a numerical value, right? So therefore you need to know that the u squared terms need to cancel off, and we need to get 2 as the numerator. So what you could do is, you can see if I put if I put 3 for b and I put -1 for a, now you can see if you find the common denominator, and if you solve this, you'll have 3u squared plus 3 minus 3u squared plus 1 in your numerator, and 3u squared plus 1 into u squared plus 1 in your denominator. You can see these two cancel off, and you'll have 2 as your numerator. That's all you need to do. Well, you could do this in your head, but if you guys want me to show of how you guys get it using the other method, please drop a comment. I'll help you guys out. So basically, it's just you multiply every term by the denominator, and you'll see you have a into 3u squared plus 1 plus b into u squared plus 1, and then you can substitute. When u equals 0, you'll have 2 equals to a plus b, and when u equals to 1, you'll have 2 equals to 4a plus 2b. And if you solve these two simultaneous equations, you get a equals minus 1 and b equals 3, right? So now you can break down the integral to 2 over 3u squared plus 1 plus 3 over 3u squared plus 1 minus 1 over u squared plus 1 dot du. Now you can also bring these two together. As you can see, they have the same denominator, so it's 5 over 3u squared plus 1 minus 1 over u squared plus 1. This is your integral. And we also had a 2 in front, right? So now let's integrate this. So what's the integration of 1 over u squared plus 1? That I can straight away write tan inverse u, right, into 2, since we have 2 in front. You don't have to worry about this. This one's actually really easy. You can do it in your head, because the integral of 1 over x squared plus 1, 1 over u squared plus 1 is tan inverse u. You guys need to remember that. But if you guys want me to show off how you get it, please drop a comment. I'll help you guys out. These are usually there in your in your formula sheets. When you go for an exam, they usually give you a formula booklet or something like that, so you'll have it. So when integrating 5 over 3u squared plus 1, well, that is pretty easy, but there's a small substitution we need to take. So we can take a substitution of, we could do it like this. We could write 5 over root 3u in brackets squared plus 1, right? And then you could take a substitution of t equals root 3u. So then dt over du equals root 3. So then dt over root 3 equals du. Right, so you go back into your integral. It's 5 over, instead of root 3 u, I'm going to write t squared plus 1, and instead of du, I'm going to write dt over root 3. So it's 5 root 3 outside over 1 over t squared plus 1 dot dt. Now we also had a 2 in front, so this is going to be 10, right? 10 over root 3. So it's 10 over root 3 tan inverse t, right? Now instead of t, I'm going to write root 3 u. So now our final answer would be 10 over root 3 tan inverse root 3u plus, it's minus tan inverse, 2 tan inverse u. Okay, and the substitution we took was u equals tan theta over 2. So then you can write 10 over root 3 tan inverse root 3 tan theta over 2 minus 2 tan inverse tan theta over 2 plus c. This is your final answer. And there's one more thing you guys need to know. So tan inverse tan theta over 2 equals to theta over 2. Now since we have 2 in front, you multiply that by 2, so it's going to be theta. So I'm going to change my answer. It's going to be 10 over root 3 tan inverse root 3 tan theta over 2 minus theta plus c. Well, you guys don't need to know this, but if you put this in your calculator, you guys can see you'll get theta as the answer. But you could leave your answer like this or like this, any way you like, it doesn't matter. So anyways, that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.